In this video, I'll be teaching you how to calculate the empirical formula of a compound from combustion analysis. Now, let's take this question. It says, a complete combustion of a 20.10 mg sample yields 69 mg of CO2 and 11.30 mg of H2O. Determine its empirical formula if it contains carbon and hydrogen only. So, in this question, we are given the mass of CO2 and H2O in milligram. So the first thing we need to do is to convert it to grams, and to do that we divide by 1000. Dividing the mass of CO2, which is 69, by 1000, we have 0.069 gram. Dividing the mass of H2O, which is 11.30, by 1000, we have 0.0113 gram. So the next thing we need to do is to find the mass of carbon in CO2 and the mass of hydrogen in H2O. To do that, we use this formula. We say the mass of carbon is equal to the molar mass of carbon in CO2 over the molar mass of CO2 times mass of CO2. In CO2, there is one atom of carbon and atomic mass of carbon is 12. So the molar mass of carbon is 1 times 12. For the molar mass of CO2, in CO2 there is one atom of carbon and carbon has an atomic mass of 12. So that is 1 times 12 plus we have two atoms of oxygen in CO2 and oxygen has an atomic mass of 16. So this is 2 times 16. Now, we are given the mass of CO2 from our question as 0.069 gram. Solving this, we have 12 over 44 times 0.069, and this gives us 0.0188. For mass of hydrogen, we have mass of hydrogen is equal to molar mass of hydrogen in H2O over molar mass of H2O times mass of H2O. In H2O, there are two atoms of hydrogen and the atomic mass of hydrogen is 1. So the molar mass of hydrogen in H2O is 2 times 1. Now, for the molar mass of H2O, in H2O, there are two atoms of hydrogen and the atomic mass of hydrogen is 1. So this is 2 times 1. For oxygen, there is one atom of oxygen in H2O and oxygen has an atomic mass of 16. So this is 1 times 16. Now, from our question, we are given the mass of H2O as 0.0113. Solving this, we have 2 over 18 times 0.0113, and this gives us 0.0012. Now that we know the masses of this element, we can calculate the moles by dividing the masses of this element by their atomic mass. For carbon, we calculated the mass of carbon to be 0.0188. Dividing by its atomic mass, which is 12, we have 0.0015. For hydrogen, we calculated the mass of hydrogen to be 0.0012. Dividing by its atomic mass, which is 1, we have 0.0012. Next, we divide by the smallest mole ratio, and in this case, it is 0.0012. Dividing 0.0015 by 0.0012, we have 1.25. Dividing 0.0012 by 0.0012, we have 1. Now, since we cannot have our subscript in decimals, we multiply by 4. Note, when you have 0.33 and 0.66, multiply by 3. When you have 0.5, multiply by 2. And when you have 0.25 and 0.75, multiply by 4. So in this case, we are going to multiply by 4. When we multiply 1.25 by 4, we have 5. Multiplying 1 by 4, we have 4. So we have carbon and hydrogen in a ratio of 5 to 4. So the empirical formula of this compound is C5H4. Now let's look at this question. It says, if the combustion of a 0.255 gram of a sample produce 0.561 gram of CO2 and 0.306 gram of H2O, what is the empirical formula of the sample if it contains carbon, hydrogen, and oxygen only? So in this question, we are given the mass of CO2 as 0.561 gram and the mass of H2O as 0.306 gram. So the first thing we need to do is to find the mass of carbon in CO2 and the mass of hydrogen in H2O. Now, for the mass of oxygen, after getting the mass of carbon and the mass of hydrogen, we add it together and subtract it from the mass of the sample to get the mass of oxygen. So we have that mass of carbon is equal to molar mass of carbon over molar mass of CO2 times mass of CO2. So the molar mass of carbon is 12, the molar mass of CO2 is 44, and in this question, we are given the mass of CO2 as 0.561. Solving this, we have 0.153. So the mass of carbon is 0.153. Now, for hydrogen, we have that the mass of hydrogen is equal to the molar mass of hydrogen over the molar mass of H2O times mass of H2O. In H2O, there is 2 atoms of hydrogen, and hydrogen has an atomic mass of 1. So that is 2 times 1, which is 2. So the molar mass of hydrogen is 2. We know that the molar mass of H2O is 18. And from our question, we are given the mass of H2O as 0.306 gram. Solving this, we have 0.034. So the mass of hydrogen is 0.034. So to find the mass of oxygen, you subtract the mass of the sample from the mass of carbon and hydrogen. Doing that, we have the mass of oxygen as 0.068. So the mass of oxygen is 0.068. Now that we know the mass of each element, we can calculate the moles by dividing the mass of each element by their atomic mass. For carbon, we have the mass of carbon as 0.153. Dividing by its atomic mass, which is 12, we have 0.0128. For hydrogen, we calculated the mass of hydrogen as 0.034. Dividing by its atomic mass, which is 1, we have 0.0340. For oxygen, we calculated the mass of oxygen as 0.068. Dividing by its atomic mass, which is 16, we have 0.0042. Next, we divide by the smallest mole ratio, and in this case, that is 0.0042. Dividing 0.0128 by 0.0042, we have 3. Dividing 0.0340 by 0.0042, we have 8. Dividing 0.0042 by 0.0042, we have 1. So, in this case, we have carbon, hydrogen, and oxygen in a ratio of 3 to 8 to 1. So the empirical formula of that sample is C3H8O. If you find this video helpful, don't forget to like, drop a comment, and most importantly, don't forget to subscribe.